So welcome back friends in the last video of our data engineering data pipeline project. So till now what we have done is we added some data into our S3 bucket from where Lambda function has checked for data validity and the valid data has been written back into S3 into a different folder, and on top of that a crawler scans the data and created a table for us. It's time to look into the table, what are the columns, and how to analyze your data using Athena. Okay, so I will open AWS console so that I can show you in the Athena. So Athena is a service, glue service only. Basically, crawler duty is only to create the table. It cannot help you to analyze. On the other side, Athena is only for analysis. It cannot create the table. So both has their own responsibility. The first part is done. Table is created. Now what we will do is I will be searching for Athena, and you can see here serverless interactive analytical service. Why we call it as serverless? Because behind the scene, when you will run a query, ultimately it needs some compute power. Just like your Lambda function was running, whenever your Python code is running, definitely it needs some storage, it needs some RAM, it needs some compute power. But as a user, we were not worried about that. That was completely taken care by AWS. That's why Lambda was known as serverless. Similarly, even Athena is a serverless service because whenever you will run a query, behind the scene there will be some server running temporarily for some time, but again, that is not the user's concern. User can concentrate on executing the query and analyzing your data. Okay, so I will be opening Athena. Okay, so let me check here. Database is data pipeline DB, it's automatically coming, and you can see the table name also. Because of that prefix, the name is coming like this. Otherwise, the name will come like only employee. So you can expand this, and you can see here. So it is displaying the column name as column 0, 1, 2, 3, 4, 5, 6, and along with that, you can see it has it has detected the data type. You know why it has not captured the column name? Because input data was having the header, but output data is not having the header. So I need to make some change in the Python code so that it can write the header also, and after that we should be good. Okay, so as of now, let me go back to our Lambda function. I think we missed that part, so I will go into the code. Okay, and the header we did not write into the output file, that's why it's happening like this. So just give me a moment. So once I'm checking the header right, after that, yeah, this should be good, and I will deploy it. Okay, so now the header should be added to the file, and accordingly the crawler should be able to detect the column names. So what we will do is we will upload the file again, because when you will upload the file once again, it will automatically trigger your Lambda function. Okay, so I will click on upload, or if you want you can delete this, or it will automatically replace, so we can directly try without deleting. So I am copying the same file again. Just give me a moment. I am just uploading from my local system. Okay, so file has been copied. Just now you can see that 1412 just now. Now I will go into the Lambda function logs just to check whether it triggered or not. So click on monitor and view CloudWatch logs. Okay. So we'll quickly check. After that, we may need to run our crawler once again because now the data has been updated, right? So just hold on. It's loading the logs and it's there. You can see the second log and yes, it is displaying reading data. This one, there are few invalid data, invalid employee ID, finally writing the data output back into the bucket. Okay, that's good. We will quickly check whether the data is updated or not. The output data and employee, and yes, you can see that. Just 1 minute back. Now, one more thing we will do quickly is we will be running our crawler, right? So I need to open my crawler once again. So in case while working on any project, if you miss something or if you get any error, right, no need to worry about. As well, try to understand what went well, what went wrong, and once you are aware like what exactly is causing the issue, you can fix that. So as soon as I looked at the column name, I realized that header is missing. That's why it is saying column 0, 1, 2, 3, 4, 5. That's not a meaningful name. So we made this change, and now what we will do is we will run this crawler. So how to run? Yes, click on run crawler. In case it will not update our column name, right, we will drop the table because the table has been already created and column name has already been set. So let's see whether it will update the column name or not. I doubt on that. In that case, what we will do is we will delete the table and we will recreate this. One table change. Okay, let's see. Query editor. I will refresh this. Okay, it's perfect. You can see that, right? One more thing we can do. Let's remove the suffix because that does not look good, right? So what I will do is I will go back to the crawler and will edit the crawler. Before running it, let's edit it. And this one, this option, right? Output and scheduling, will edit this and I will remove the prefix. Okay. And click on next and update. Cannot update crawler while it's running. Please stop crawl or wait until it completes. Okay, maybe it's in running state. That's why. No worries. We'll check. It's not in running state, right? Okay, we'll try again. So I will select this and edit. Editing the last section, removing the prefix. So it was only for your learning, like you can add some prefix if you want. So I am updating my crawler now. Okay, updated, good. And I will run one more time. This time I am expecting that it should change my table name also. Column name at least are coming perfectly fine because now this time your output data has a header, and from the header your crawler is smart enough to take the column names. So just wait for a few more seconds and we should be good. Okay, I think it has not changed because you can see that there is no change. So I'm going back to query editor. I will refresh this. Seems like table name is not updated. Okay, the previous table is also there and new table is also there. Okay, no worries. So let's try something. We will try something like select star from employee. Okay, so you can notice that there is no permission for this particular user because I'm logged in as a IAM user. You can see that IAM underscore Neeraj, right? And I do not have permission to execute a query on this. That's why it is not allowing me to run. As I explained in the beginning, right, whenever you are getting an IAM role, it should have the required permission. So I think I need to add some permission over here, and for that one, I need to log in as a root user. Okay, so I will show you so that you understand, like, whenever you face any issue, how to deal with that. So first of all, I will log out as a IAM user, and I will log in as a root user. Okay, so I will sign in back. Okay, so I will sign in as a root user and I will provide the email address, this one, June 2023. Next. So I have enabled MFA, that is multi-factor authentication. It is to make your AWS account more secure to avoid any misuse. So it will ask for a MFA code which is available in my mobile app. Just give me a moment. I need to take the code from my mobile phone. Just allow me. So it's a 6-digit code, just like a OTP. So let me enter that. It's 754707. Okay, that's good. Okay, so now I have logged in as a root user. That means I have full permission. I can do anything. So what I will do is I will add some additional access to that IAM Neeraj user. So I will go to IAM first. Okay, and I will go for users. There is a user with the name IAM underscore Neeraj, right? This one I will click, and few permissions are already here: SNS, Cloud9, code build, code commit, code pipeline. But you notice one thing: there is no permission attached for Athena. That's why I was not able to execute the query. So what I will do is I will click add permission and I will search for Athena. So Athena full access, or this is Grafana something. So basically let's go with this one. That would be good. And click on next and finally add permission. So basically I am allowing this IAM Neeraj user to do anything on Athena. So that's all. We are good now. I will log out from here. That's my root account. I'm because it's not recommended to do the development stuff using root account. Root account should be mainly used for managing your, I can say, users, your uh, different team members are there, right? Giving some permission, removing the permission, creating the groups, and doing some admin level activity, but not the development stuff. That's why I'm signing out from my root account. I will be logging in back with my IAM user, and I have enabled MFA for my IAM user as well. So I will select with IAM user, IAM Neeraj, this one. Next, uh, okay, it's asked for MFA code. Just give me a moment. I will check on my phone. 801580 and submit. Okay, so we are back. We are logged in as a IAM user, and earlier we were facing some issue with our Athena. Hopefully, we will not get now. So I'm clicking on Athena, and we'll try to run some query. Okay, and you can notice one more thing. Before you run your first query, you need to set up a query result location in Amazon S3. That's a requirement from AWS side. So it's very simple. You click on edit setting and provide some output path. So what I will do is browse, and this is my bucket, and definitely I cannot use these two because this is for my input and output data. For this one, uh, for Athena, right? I will change it. I'm just selecting this now, but I will change that. Okay, I am just selecting this path, but I will change it. So instead of output data, I would say Athena output data. Okay, so basically this folder will be automatically created and will be holding the output of your Athena query. This is a mandatory stuff from Athena side. So that's all. You click on save. That's one time setting. You don't have to do it every day. Okay, and coming back to editor, and we'll start with very basic. Select star from employee and let's run it. Hopefully this time will not get any error, and it's perfectly running. You see that employee ID, first name, age, gender, department ID, and manager employee ID. And did you notice one thing? Whatever invalid data were there, where additional value were there, missing values were there, and missing employee IDs were there, those are not, well, not here, because that Lambda function has already filtered out during the Lambda function execution, right? This way, using multiple AWS services, we can create a end-to-end data pipeline. If you want to try something else, you can do anything here. You want to join two tables, that means you should have two folders which will contain two different type of data, and your crawler will run through it and it will create two tables for you. And then you can join those two tables. You want to join left outer join, right outer join, you want to use some inbuilt functions like count, you want to do min, max, average, anything you can do. We have age, right? Let's do min and max age. Okay, so select manager employee ID, count star from employee. I'm removing Apollo, I'm just putting employee. Group by manager employee ID. What it will do? It will display how many employees are there under each manager. So let's run this. And you notice one thing, it will display only manager employee ID. It will not display manager name. If you want to display, you have to join self join by itself. So manager employee ID 003, and under that employee only, under that manager only one employee is there. Under employee 007, 2, 3 and 1, like this. If you want to display the name, right, you can join it. Shall we try that? So let me do one thing. I will do okay, so I will do okay, this is one table, we have to join it, right? Select name, m dot name, manager dot name, okay, and employee dot count. I'm changing the query, just give me a moment. Manager dot name and count from employee, as m, and then joining this entire table. We'll give some name like E. Okay, not employee ID. We are just giving some alias E. Give me a moment. His autocorrect is creating problem. E on m dot m is for manager, right? So m dot emp id is equal to e dot emp id. Okay, let's try to run this if that fulfill my requirement. something is wrong. E dot employee ID. Okay, okay, I have to give some name here. Count star as employee count. I'm just using this. I can use it here, and this one I can select as. We can use the same. Okay, it's perfect. You can see that. And if you want one more thing, you can display employee ID also. Not an issue. E dot manager ID. You can do like this. Okay, so what it will do is it will display the manager name, it will display the manager employee ID, and it will display how many employees are under that manager. You can see now it's quite good output. So employee, not employee, basically manager. Manager name, or if you want, we can quickly make a small change. M dot name as manager name. Okay, it will look good. You can see that. So these are the manager names: Neeraj, Sahil, Mahesh, Ritesh. These are their employee ID, manager's employee ID, and how many employees are under those managers. So under Neeraj there is one employee, under Sahil there are three employees, Mahesh two, Ritesh two. So this is only very simple example. Once your table are created in Athena with the help of Crawler. So Athena and Crawler are, you can say, work together. Crawler is scanning your data and creating the table. Athena is analyzing the data by querying on those tables. So this way these things work together. Okay, I'm opening the architecture diagram once again so that you can understand it, like what exactly we have achieved till now. So we started with uploading a text file, CSV file, into our S3 bucket. Our Lambda function discarded the invalid rows and valid data written back into S3. Then the crawler ran and it went through your header, your file. It automatically detected the employee name, column name and their data type, and finally created the table into Glue database. And Athena, which is linked with Glue database, can easily execute the query on that. The good part is there is no actual table. In RDBMS, we create the table, we load the data into the table, and there is actual table exist. But Athena on the other side, it directly plays on your input data. That means if you delete the data from S3 output folder, your table will not work because there is no actual table. There is a schema and there is the data. Schema is mapped with the data. Athena only knows that there is a employee table, and behind employee table there is a file stored in S3 bucket. So at runtime, when you are executing the query, basically it reads the data from S3, it analyzes it, and finally displaying it as a table on the query editor, and finally you think like it's coming from a table. But actually Athena works on file level, it directly coming from the file. Okay. So friends, this is all about our data engineering data pipeline project. I hope you understood end to end. We started from input data and finally using various AWS services, we finally completed this data engineering project. So please leave your comments in the comment section. And if you like the video, please like it, share it with your friends, share it with your colleagues, and also subscribe to my channel because I'm planning to create these type of projects almost every week. So every week I will be creating a project mainly on Sunday so that every week you can get the notification for upcoming projects as well. So that's all. Thank you.